Hello, my name is Patrick Dowden. I'm with Automation Southwest. What we're going to do today is run through a machine vision application we put together for Cartamundi. We're working with the maintenance manager of the plant. Out at the Cartamundi plant, there is some existing machine vision technology. What we're going to run through here is the Data Logic PPT Vision Impact software. We're going to try to make a few pointers of how this software works and let you guys at Cartamundi have a comparison between what we have here and what you're using today. The software that's on the screen right now is the Vision Program Manager half of the Impact software. We're running in an emulator mode, but the image you see here, like this 8 for instance, and I can click through a few others, these are images that we captured with an actual A20 camera when I was out at the plant floor. On a few of the images, what you'll see is the border around has been cut down. We actually used a pair of scissors to do that intentionally so we could introduce some failed images for purposes of the demonstration here. Our software is a drag and drop type of software. There's a toolbox column on the left. Within here, you'll find graphical tools that can be dragged into the program. The program is basically this image and task column. For this application, it was a very, very simple analysis. We used an origin tool that lets us adjust the position of our tools. The subject of an inspection, is it perfect? If it bounces around a little in the field of view, this lets us move our tools in relation to where the card is detected in the field of view. Then we used a couple of line gauge tools. Basically, these measure the length of a line. In this case, what we're looking at is the thickness of a white border on the top of the card and again on the side of the card. And the thickness of that border determines the quality of the printing. As long as it stays within a tolerance band, we're going to pass it. If it gets outside of that tolerance band, we're going to fail. The only other tool that was really relevant is the pass-fail. What this did is it took the pass-fail result of the origin tool, the line gauge top, and the line gauge side, and summarized it into an overall pass-fail for each card. There are a couple of basic tools on here. I wrote those in to just add a little cosmetic feature to the control panel manager's part of the software, and I'm going to get to that in a second. That's the operator interface half of the software that is included in the Impact overall software. So what I'll do here, I'll let the machine, I'll put the emulator in run mode, and we'll click through a few images. As we go from image to image, you'll see a few of these turn red in the line gauge. And what that's going to indicate is we found a card that was outside of the tolerance. So a better way to demonstrate this is to go over to the control panel manager and take a look at what we have here. The first thing you might notice is in the control panel manager, I'll go ahead and put it online, you'll see this is oriented the opposite. This is 90 degrees off of what was in there. For purposes of just cosmetic display, that's a checkbox. I can turn things 90 degrees up or 90 degrees back or 180 degrees if I want to for purposes of the angle of the camera versus the presentation of the information to the operator. Overall, what's on the screen here are the results of the tools in the image and task. Structurally, what we have here is the machine vision program from VPM, from the Vision Program Manager, is displayed right here. This is the actual program from the other half of the software, and we use this program to drag and drop image elements over into the graphical part of the screen, and we tie things back with some data sets and gets. So if I put it back in run mode, one of the major parts of this inspection is tolerance. We're going to pass or fail based on the width of the band on the side and the width of the band on the top. This set of tools is the pass band, if you will, for the top border. So right now, we're expecting it to be approximately 0.1685. That would be an ideal card. And I just measured that with calipers and plugged that value in. And then we're going to allow anything that's minus 162 or minus 0.0625 or plus 0.0625. And those little areas where you saw me write the little snippets of basic code, that's where these values are coming from. So if I come into the minus value and I increase it, not only am I increasing the tolerance band here, I'm allowing more minus to pass through. This is the actual raw data. This is the engineering value in inches. I did a conversion in the Vision Program Manager of pixels to inches, so everything we're seeing on here is actually displayed in inches. So for purposes of pass-fail, as these images click by, you're able to determine the length of this arrow, if it's long, if it's short. If it's outside the value of the tolerance band, then that individual tool will fail, which will lead to the overall fail in the top corner here. So I guess in summary, I would say we have a very strong machine vision application. We're able to put together a nice little operator interface in a relatively few minutes. We're able to display the actual values of each tool on the screen. If we were able to invest a little bit more time, we could do things such as store failed images and display the last few fails, and that sort of thing is very common. But overall, I would say we have a very nice working machine vision application. Again, my name is Patrick Dowden. I'm with Automation Southwest. If you have any questions on this application, please don't hesitate to get in touch with us. Our website is automationsouthwest.com, or you can reach us at our office, 214-901-7677. Thanks very much for your time.